0.28. Oh, I got a little race happy. Because it needs to be like 8 divided by 9 pi in your calculator. So either the fraction or bracket. All right, fundamental theorem of calculus, greatest thing ever. So what we learned that if you do left endpoints or right endpoints, it could over-exaggerate the area or under-exaggerate the area. The midpoints gets a little better, correct? But still not accurate areas, yes? But the fundamental theorem of calculus will get you the exact area. So let's write it down. If I wanted the area, so let's look at the one we just did. So the one we just did was the area. I asked you to find the area of y equals x squared plus 1 from x equals -1 to x equals 2. All right? The area from y equals x squared plus 1 from x equals -1 to x equals 2. I asked you to do that with right bounds. I asked you to do it with left bounds. I asked you to do it with midpoints. And we got kind of close. We have some different answers. We had our right endpoint, we got 8. The left endpoint, we got 5. And then we got 5.75 for the midpoint. Correct? Okay. How do we do it actually? So, we have to find the antiderivative. The antiderivative will always get you the area under a curve. So remember the first derivative got you the slope, the tangent, right? First derivative got you slope, tangent. I asked you for tangent lines. If I gave you the distance formula, it would give you velocity, and velocity would give you acceleration as we work through our derivatives. The great thing about working backwards is if I want the area under a curve, I just do the antiderivative of something. So you're going to get an integral symbol. So this is what it's going to look like. Area equals, it's like a fancy L. You look at the white textbooks. I drew it backwards. Oh, that's great. I think I did. Pray for me. That way. Fancy S. It's like if you want to write an F without a little lining in it. Okay. So it's like an F of X without the... Yeah, that's what I always think when I see it.
I love on the side curve.
Okay. So... Now what we have to do is we go -1 to 2. We're going from -1 to 2 because that was the x values that we were looking at, low bound, high bound. So you always go low to high. If they happen to be the other way around, you can switch them by taking a negative sign out. So for example, if I had written it as, or I had given you one, and it looks like this, I could rewrite it as -0 to 4 f of x dx. You always go low to high. If it's not giving to you low to high, you can take a negative out and it'll flip it. All right. So what we have to do is we write the integral symbol, -1 to 2. Then we write our equation, x squared plus 1. And then we follow behind with a dx. Because that just means we found the derivative of x squared plus 1. The dx says that that is actually a derivative, the first derivative. Okay? Now, we have to anti-differentiate it. So, what we're going to do is we're going to do the antiderivative of it in the ways that we learned. Add an exponent, right? Add 1 to the exponent, divide by that number. Nothing crazy, same thing. So, what we do is we write equal to, and I'm going to do the antiderivative of it. So I'm actually going to find the original. So the x squared becomes x to the 3. And then what do I get in front? A third. Plus, what happens with the 1? It becomes 1x. And then what do I always get behind this? Because I don't know if it was there. Plus c. Now, if it was an indefinite integral is one that's not defined. So it looks like an integral symbol, but it doesn't have the numbers. It's like your general area. then you would stop there. That's all you could do. Okay? But this one is actually defined from a low to high. So what we do is we can't keep the integral symbol there to say that it's from -1 to 2. Because if we kept the integral symbol there, it would say that we didn't work back. It was still a derivative, correct? So what they make us do is you put a little box in the back like this, a little bracket, and you go -1 to 2. So now I have the original graph, correct? You can always recheck that you did the antiderivative correct by deriving that and seeing if you get it back, right? If I derive 1/3 x cubed plus 1, I'll get 3 times 1/3, so that goes away, x squared plus 1. Ah, look at that. It matches. Okay? Now this is where the fundamental theorem of calculus comes in. What you do once you go back to your original question is you're going to plug in the top number minus plugging in the bottom number. So you're going to substitute in the top number minus substitute in the bottom number, and it'll get you the area in the curve. So what does that mean? That means this. We're going to go in brackets and plug in the 2 first. So I get 1/3 2 cubed plus 1 times 1/3 plus c minus, oh, why did I put 1/3? It's a scary thing sometimes. 2. I had a third over here and wrote it. 2. And then we're going to plug in -1 and we're subtract. So we get 1/3 -1 cubed plus 1 times -1 plus c. So we didn't find out what the c's are, but they're actually not a problem. Because in the first equation I'm adding c, and then if I distribute that negative sign through, what's it going to do with the other one? Subtract c, so they actually cancel off. Okay? So we don't have to find the c's like we did when we were working our way backwards. We just have to math now. So I get 2 cubed, which is 8 times 1/3 is 8/3 plus 2 minus -1 cubed is -1 times 1/3 is -1/3 times negative is positive 1/3. And then I get -1 times 1 is -1 times -1 is 1. So I actually have, a lot of people try to make common denominators here. You don't have to. I'm going to get 8/3 plus 1/3, which is 3. Yeah, 9/3 plus 2 plus 2. 2 plus 1, oh my gosh, is 3. So it's actually 6. That's the actual area under this curve. The midpoint was pretty close, but not completely accurate, right? So, does this mean that you never have to do right bound, left bound, and midpoints?
No. Yes.
No. Yeah, it'll come back. Okay, so I'm going to give you another one to try. Okay? So, determine the area. F of x equals x cubed minus 6x from 0 to 3. Go. So, we have the area equals, now we have x cubed minus 6x from 0 to, go away, 0 to 3. And you have to remember to put the dx, and I guarantee you 90% of you forgot. All right. Okay. Let's do the antiderivative. What's the antiderivative of x cubed? 1/4 x4 minus 6x to the 2 divided by 2 plus c 0 to 3. And this is just a 3. So I'm going to get 1/4 3 to the 4 minus 3 times 3 squared plus c minus 1/4 0 to the 4 minus 3 0 squared plus c. This whole thing cancels. And then here it's 81 over 4 minus 27. Those are gone. What do you get? What? What? What do you guys?
Isn't 6.7?
Negative 6.7. That's what I was saying.
I was hearing negative 27, which is not even close to it.
Yeah. Which is that?
No, it's right.
Okay, cool, we're there.
I did it right. Can't handle it.
Under the x-axis. It varies under the x-axis, it's called negative. Okay, shh. Paying attention. It was a good question. How can area be negative? More of the area of the graph is under the x-axis than above the x-axis. Therefore, you get negative. Also, when you're doing right and left areas, if like part of your graph is below, and you get a negative y value at like f of 0, you have to use the negative y value. Your widths will always be positive, but your legs can be negative. So if you end up with a negative area, it means more of the graph is under the x-axis than above the x-axis.